Okay guys, let's take a look at these notes. So the first thing it asks us to do is fill out perfect squares, perfect cubes, and perfect fourths. And perfect squares we should be pretty familiar with. I'm just going to write some of them. 1, 4, 9, right? 1 squared, 2 squared, 3 squared. You could keep going. On your notes you should keep going. Try to get at least the first 10, okay? Then perfect cubes. I'm going to start with 1, that's 1 cubed. Then 8 is 2 cubed, and 27 is 3 cubed. Okay, you should keep going again. Try to get to the first, at least the first 9 on this one. Maybe you could do more. Then you've got perfect fourths. 1 to the fourth is still 1, right? 2 to the fourth is 16, and 3 to the fourth is 81. On your new notes, you should keep going again. Okay, so this is just a little exercise to help us keep refamiliarize ourselves with squares, cubes, and fourths. So if you want to pause the video right now and finish this, you should do that. So now let's look at parts of a radical. Okay, and it says the nth root of the real number a can be written as the radical expression, and that says the nth root of a is how we would say that. Okay, so this n is called our index, okay? Our index, I-N-D-E-X, index. Then the this like sign is called the radical sign. And then a is called the radicand, so what's under the square root, okay, or under the radical sign, because in this case it's the nth root. It doesn't just have to be the square root. Is the radicand, okay? So we need to get familiar with this terminology, the radicand. Now, if there's no index, so if there's not an n value listed here, which is what we're used to, right, then it's assumed that n equals 2, and that would just simply be the square root, and we're used to that, so that shouldn't be unfamiliar to us. Okay, I'm going to do one example of each here. All possible roots for this would be positive and negative 4, right? Square root of 16 is 4. All positive roots would be the positive and negative. Okay, the cube root of 8 is 2, and it actually couldn't be negative 2, because if we took negative 2 and cubed it, we would get negative 8. So in this case, it's just negative 2, or just positive 2. And then the fourth root of 1 is positive or negative 1, because if you took negative 1 and to the fourth, that would be 1, and then 1 to the fourth would be 1. So you just try these out. For each of these, give all possible roots. Okay, I want to fill out this chart completely for you, and then I'm gonna let you work on the rest kind of by yourself. But if you have if the index is even and the radicand is positive, you're going to have real roots, and you will have 2 roots. Okay, one will be positive and one will be negative. If your index is odd, so if it's like 3, 9, 13, right, you will have real roots. If the radicand is positive, you'll have real roots, but you only have one of them, and it'll be positive, okay? If your index is odd and your radicand is negative, you will have real roots, okay? But you only have one, and it will be negative. And then last, when we kind of started talking about this, is if you have an even index, negative radicand, you're going to have imaginary roots, okay? And there will be 2 of them, positive and negative. Okay, I want to work one example of these for y'all. You guys know how to simplify square roots, but if we have any index, the key here is when we break these down, we're looking instead of for pairs, because 2, when the index is 2, we're looking for 3, when the index is 3. So if we break 48 down, right, we would get that it could be 8 times 6, and then 6 is the same as 2 times 4, it's 2 times 2, and 6 is 2 times 3. So here we've got this set of 3 2's, and then these don't have any sets of 3 there. So our cube root would be 2 times 2. This came out the cube root, and then cube root of 6 is what was left on the inside. Okay, so it would be 4 cube root of 6 is our final answer there. And if that's a little confusing, I just want you to really take your time and think about it. Okay, think about the fact that when we took the square root, if they had pairs, you bring it outside, and so when we take the cube root, we would have 3 come out to make 1. If you're taking the fourth root, it's going to take 4 coming out to make 1 on the outside. Just kind of think about that concept. The last thing, I'm going to have to add a page, sorry, is I just want to give you the answers for your next little section, okay? So for right here, square roots, your exponents must be exponents of 2. Cube roots, exponents must be multiples of 3, and fourth roots, exponents must be multiples of 4. Okay, so use that and try to do the rest of this first page, the first 2 pages by yourself, using each other as a group.